In this module, you will learn about condensation polymerization or step growth polymerization, a type of polymerization reaction. You will also learn about the methods to prepare some important condensation polymers as well as their uses. In condensation polymerization, the molecules of a monomer combine with the elimination of simple molecules such as water, alcohol, and ammonia to form a polymer. The polymer so formed is called a condensation polymer. You already know that condensation polymers are the result of repeated condensation reactions between two different bifunctional monomers. Hence, this type of polymerization also involves a series of reactions, just as in addition polymerization, but it differs in the aspect that each step is independent of the preceding one. The series of reactions in condensation polymerization is attributed to the presence of more than one functional group in the monomer. In other words, the formation of a polymer is possible as the monomer can undergo reaction at more than one functional group. The product formed in each step of the reaction as a result of condensation between two different bifunctional monomers also has a bifunctional group that can further react with another monomer to form a larger molecule. The series of such reactions continues. The stepwise condensation of monomers, which results in the formation of a polymer, is called step growth polymerization. Illustrated here is the condensation reaction between ethylene glycol and terephthalic acid polyethylene terephthalate, PET, also known as Dacron. Note that in each step, when two different monomers combine, a water molecule is eliminated. Let us now see how some important condensation polymers are prepared and their uses. Polyamides, polyesters, phenol formaldehyde polymers, and melamine formaldehyde polymers are all important condensation polymers. Polyamides are polymers that have amide linkages. Polyamides may be naturally occurring, such as proteins, or synthetic, such as nylons. Nylons are commercially important synthetic fibers. The general reaction to obtain polyamides can be described as the reaction of diamines with dicarboxylic acids or dibasic acid to form amide linkages. Several different forms of nylon have been synthesized. One important nylon polymer is nylon 6,6. To obtain nylon 6,6, adipic acid or 1,6-hexane-dioic acid is made to react with hexamethylene diamine or 1,6-diaminohexane at a high temperature of 553 Kelvin and high pressure. This polymer is called nylon 6,6 because there are 6 carbon atoms in each monomer, adipic acid and hexamethylene diamine, that participates in the reaction. Nylon 6,6 is used to make sheets, bristles for brushes, textiles, and tire cord. Nylon 6 another synthetic fiber, resembles the properties of nylon 6,6 closely. To obtain nylon 6, caprolactam is subjected to prolonged heating with water at a high temperature of 533 to 543 Kelvin. Nylon 6 is known by its trade name, Perlon L. It is used to make tire cords, fabrics, and ropes. Polyesters are another important group of condensation polymers. The general reaction to obtain a polyester is a condensation reaction between a dicarboxylic acid and a diol. Dacron is the trade name for polyethylene terephthalate, or PET, a common polyester. To make Dacron, ethylene glycol and terephthalic acid are reacted at 420 to 460 Kelvin in the presence of a zinc acetate, antimony trioxide catalyst. The structure of the repeating unit is shown here. Dacron is crease resistant. Therefore, it is often blended with cotton and/or wool. It is also used as glass reinforcing material in safety helmets. Can you write the equation for the formation of Kelvar via a condensation reaction from the monomers shown here? These two monomers can form a polyamide chain with para or 1,4 linkages. Notice that HCl is formed during the condensation reaction. Kevlar fibers are very strong as many hydrogen bonds are present between the chains, as shown in the illustration here. Kevlar is used to make protective gear, including bulletproof vests. It is also used to make a variety of sports equipment, including boats and tennis rackets, besides puncture-resistant bicycle tires. Phenol formaldehyde polymers are another important group of condensation polymers. The first step to produce a phenol formaldehyde polymer is the condensation reaction of phenol with formaldehyde in the presence of an acid or a base catalyst. This results in the formation of ortho and/or hydroxymethylphenol as shown in the equation. In the subsequent steps, the hydroxymethylphenol derivatives react further with phenols to form polymers with rings joined by CH2 groups. For example, the linear structure shown here, known as Novolac, is used in paints. When Novolac is heated with formaldehyde, many cross-links between the chains develop. This cross-linked, rigid three-dimensional structure is called bakelite, the first synthetic polymer that was ever developed. Bakelite can be used to make combs, phonograph records, electrical switches, and utensil handles. Bakelite is also used as a porcelain substitute, such as in game pieces. Another important condensation polymer is the melamine formaldehyde polymer. The first step in the formation of this polymer is the reaction between melamine and formaldehyde, which results in the formation of a resin intermediate. The resin intermediate undergoes condensation polymerization to form melamine. Melamine is used to make unbreakable crockery. It can chip and scratch. However, it is not microwave safe. Melamine is also used to make fireproof jackets. Note that both bakelite and melamine are thermosetting polymers. You have now reached the end of this module. In this module, you learned that in condensation polymerization, the molecules of a monomer combine with the elimination of simple molecules such as water, alcohol, and ammonia to form a polymer. Condensation polymers are the result of repeated condensation reactions between two different bifunctional monomers. The general reaction to obtain polyamides can be described as the reaction of diamines with dicarboxylic acids or dibasic acids. Nylons contain amide bonds. Nylon 6,6 is made from two different monomers, while nylon 6 is made from a cyclic monomers. The general reaction to obtain a polyester is a condensation reaction between a dicarboxylic acid and a diol. Dacron is the trade name for polyethylene terephthalate, or PET, a common polyester. Bakelite is a phenol formaldehyde polymer with many cross-links. Melamine is a melamine formaldehyde polymer. Bakelite and melamine are both thermosetting polymers.